All right, I'm just going to do a quick, let's see, I'm going to just do a quick little overview on ANSYS real quick, and then I'll pass it along to Salman here. So
Okay,
when
great.
you're ready.
Okay. Yep. So welcome everybody. And so this is our last day of class for this semester. And so we're very fortunate to have two special guests today. And so just like I promised, and so we have Aled and we have Salman here, and they're going to tell you about their industry perspective on ANSYS. And so I won't take too much of their time, and so I'll just let them kind of get rolling from here.
Okay. Thank you, Justin. Hi, everybody. My name is Waleed. I oversee all the academic, the program in the western part of the United States. And so I've asked my colleague Salman to join me today and present to you the industry take on ANSYS. But before we jump in, I just wanted to just show a couple PowerPoint slides to familiarize yourself with our like our website, what offerings we have for you in terms of like courses and things like that, and just to make sure you're aware of our ANSYS academic kind of program here. So let me just share my screen and my PowerPoint here. All right, yeah, feel free to connect with me on LinkedIn. If there's anything I can help you with, I'd love to do that. So real quick, just kind of showing you this slide right here. I just wanted you to be familiar with, you may recognize some of these companies. And what I want you to familiarize yourself with is all the industries that these companies belong in. You know, we have customers in aerospace, in automotive, in construction, in oil and gas, electronics, consumer goods, med device. So we're all over the place. And if you recognize these some of these companies, then what you may or may not know is that they use ANSYS. And so one of the cool things is that since we provide them with licenses, and so we work with them, they often come to us and ask us for resumes or any graduates that have certain experience in certain ANSYS applications. So our goal here is not just to, hand over ANSYS software to you and say, here you go. Our goal is to partner with the universities to help you, get exposure to ANSYS, learn about ANSYS, and as much as possible, as much as you want. That way, when you put it on your resume, or that way, when you want to market yourself, you'll, be able to stand out and differentiate yourself with others that may just have, let's say, 3D modeling experience or very entry level FEA experience. And so, just some additional data on just showing you, like, engineers it's getting more and more popular now for design engineers to get exposed to simulation. And so we have a lot of companies also looking to do that. They're trying to find ways to minimize waste spending on prototypes. And so if they can do a lot of the upfront simulation, even at the design level, very early before it gets to the analysis level where they're doing validation and stuff, that can help produce a better product overall, and then just reduce the prototyping costs. But what we're, the reason why ANSYS is very motivated to work with universities is we're seeing that we just want to get as many graduates and students as possible getting exposure to ANSYS. We're just seeing that, we just want to help, make it easier for you to get out there and get jobs. And so the ANSYS academic program includes sponsorship. So if you're on a student team, if you're doing a student project, senior design project, or if you're on the graduate level, if you're doing any type of research project or something, we would love to work with you. Make sure you've got software if you need it, and make sure you've got training material. Let us know. You have licenses available on the university, but sometimes you may, want to have your own license. We do have free licenses, which I'll talk about later, if you want to install it on your own personal computer for any other type of educational research and stuff. This is a pretty interesting little screenshot that I want to show you. So we can all say we know CAD 3D modeling, right? Maybe you'll pick, your favorite tool, or We can all say we know Microsoft and things like that. We can all say we know FEA or CFD modeling. But what we notice too is when you also say that you have ANSYS experience, that just gives you that much more leverage. And it also leads to a higher salary job as well. The companies that are paying for ANSYS commercially, they're spending a ton of money. They're spending, a lot of money on the software because, it's the results that it gives is very accurate. And so, it's just something that a lot of companies focus on. So, that's great if you have FEA experience in a lot of different applications. And if you can add ANSYS to that, that's only going to help you stand out a little bit more. I usually show a video here. This is just from a student's perspective who actually was in college, knew FEA through like SOLIDWORKS or Autodesk, but at some point got exposed to ANSYS simulation, which helped him get into a very good university. A very good graduate program. And then from that graduate program, got himself into Cornell and then, was working for a pretty reputable aerospace defense company. So it's just a way, again, my whole point with this PowerPoint is just to help you be more competitive out there in the engineering field. And so this is a YouTube video. What I'll do is I'll share a link in the chat if you want to, bookmark it or watch it later on. This is another video that I typically show, and I just didn't want to take away time from Salman, or else I would play this for you as well. But this is just the professor's take on why simulation is important and what he's seeing from graduates as they go out there in the real world. So I'll make sure I share that link as well. I mentioned a free ANSYS tool. So yes, the university offers ANSYS through the licensing program you have there. But if you may also download a free copy on your own personal laptop if you want as well, and that'll include Discovery, SCADE, ANSYS Student, which in ANSYS Student it's it's mechanical. I don't know if you're familiar with our products, ANSYS Mechanical, ANSYS Workbench, ANSYS Fluent, and some of our other leading tool sets in FEA and CFD. We also recently added LS-DYNA, so that's a great add there for students. And if you're interested to learning a little bit more about it or going there to get a download, the licenses are good for 1 year, but it's just ansys.com/students. This is really important. I think the key takeaway also is the learning forum. So we've devoted a lot of time and resources and attention to this site. Basically, this is your one-stop shop for any type of tech support type questions, peer-to-peer kind of discussion on, a particular problem you're trying to solve. And you can also communicate, with our experts as well. So we have a lot of our engineers at ANSYS using that as well to provide feedback or answer questions that students, professors, teachers' assistants, people in all sectors of the academic space. It's just a great place to kind of make sure you have bookmarked. So that's ansys.com/forum. You will need to register for a free account, but it's a great place to go, just to have in your back pocket. Another great resource we've been developing this past year is the ANSYS innovation courses. So what we wanted to do, we realized that people are going to YouTube for videos. They may go to find other learning material on various websites like the Cornell Sim Cafe, for example, and things like that, which is great. What we wanted to do is we wanted to have kind of our own ANSYS curated courses. So we're constantly adding more and more courses here. And the cool thing is we've worked with professors all over the United States, and I believe also maybe even overseas. But so we've curated these courses, and as you go through them, it's like a little mini course that has like quizzes, homework assignments, and at the end you get like a certificate or a badge. But it's also good for extra practice. So if you're in class and you just need more practice on this particular area, or want to start familiarizing yourself with some other case studies, this is a great place to go. When you register for the ANSYS Learning Forum, you'll automatically have access to this. But so either way you go, ansys.com/courses or ansys.com/forum, both of those are linked together. And so you'll be able to get to both of these websites very easily. We recently added Granta materials to this too. So I know it says fluid structures, electronics, and STEM. STEM is like 3D modeling, ANSYS discovery, but we also added materials. So we're going to be adding about 7 to 8 more videos by the end of the year there as well. And so we've got a ton of videos in there that you could take advantage of and watch at your leisure. If you're interested in just, adding more resume boosters, right? Or just wanting to get more exposure to ANSYS outside of school, you can go to the Cornell program that we have, where it's a hands-on introduction to engineering course, but it has the Cornell stamp on it. It has an ANSYS stamp on it. Again, you get a nice cert after you go through the course. If you want to get a cert, I think it costs some money, like $50 or $100 or something, but you get a nice, really prestigious certificate. And then you get to, throw it all over your LinkedIn, your resume, and you get to boast about it when you're out there marketing yourself. So that may be something interesting for you. Earlier, I mentioned student team sponsorship. If you have any, classmates or anybody that's part of a student team, it's always good to have as many tools in your toolbox as possible. So if you're, if you have the other, FEA or CAD applications, that's great. Add ANSYS to that. It's always helpful to have as many as possible, because you're always going to have 1 or 2 people on your team. One person is going to be more familiar with SOLIDWORKS. One person is going to be more familiar with ANSYS. One might be more familiar with, Siemens products or whatever. So everybody can kind of have exposure and just work together and have the tool they're more comfortable with. And it's available. It's free. You get to use our ANSYS logos and things like that. And you get to also just include it in your, advertisements and things like that. ANSYS.com/teams if you're interested in learning more about that. This is interesting. This is from a person out in the real world, an engineer who basically went back to learn more about ANSYS, got exposure to HFSS, and then just simply putting ANSYS HFSS on his resume really made him, move up in terms of like where his pay grade was, or what his, kind of level was, and from being like an electronics simulation expert, for example. So I don't know if you've never heard of HFSS. It's class leading high frequency simulation solver. It's a very sophisticated tool, and it's very respected in the electronics community. So just think about that. It's if you're interested in learning more about ANSYS, there's a lot of other applications that you may have interest in, and you might find that you can learn pretty easily and just kind of get exposure to. Here, the interesting story about this is we had a student team that won the Hyperloop contest and whatnot, and these folks used ANSYS, and they were able to spin off. After graduation, they were able to form their own company. And so what they do is they only hire from fresh graduates and stuff, which is kind of cool. So that their success story they try to repeat over and over again. And so it's pretty cool. Hopefully that's inspiring for you. We have like startup programs and things like that as well. If you've got an idea with a group of people that if you want to start up a company, but for example, ANSYS might be a little out of reach financially, we do have startup programs and stuff like that too. So to help you be more successful. That's all I really want to tell you. Again, I don't want to take too much time from Salman. And what we'll do is after the presentation too, I think we might save enough time for Q&A. But if you want to throw something in the chat or ask a question in the chat, feel free to do so. And I'll let Salman kind of figure out if he wants to just answer it mid-presentation or at the end. But we'll be here working together to make sure we answer all your questions. So thank you for your time. And Salman, take it away.
Hey, thanks, Waleed. And thank you to Justin for having us today. And thank you to all of you for being here today. So hello, everyone. My name is Salman Kalkhoran. I'm a lead application engineer with ANSYS, and I'm based out of Irvine, California, so not too far from CSU Fullerton. So it's a pleasure to be here today. And really what the objective here is to show you guys some of the applications with an application focus of ANSYS and how it's being used in industry. So really the title of this talk today is going to be Driving Innovation with Simulation, because as Waleed mentioned, many of the companies that are currently out there are using our simulation tools in order to better their workflows, as well as improve their overall product design, as well as time to market. So as Waleed alluded to earlier, we do have simulation tools that are really spread out in terms of physics capabilities. So we cover computational fluid dynamics, so any type of fluid flow or heat transfer that's based on a fluidic physics, that would be done with our computational fluid dynamics tools, namely Fluent and CFX. But really the topic of today is going to be focused on the structures portion. So ANSYS Mechanical is the structural tool that we use, which is based on the finite element method. Now, many of you may have used ANSYS in the past or learned about FEA in general, but really what we're looking to do today is to cover some of the applications, like how do we take a simple beam model or simple, component model and think about more industry focused types of applications where we can actually attack some real world problems and answer some real world questions. So if you live in California, you know that we're essentially dominated by four major industries in the area. One is aerospace and defense. The other is automotive, especially with the rise of electric vehicles and also the government's suggestion that, all companies become all electric by 2035. Automotive in California is being very, very focused on electric cars. And then we also have a lot of healthcare companies where, innovation is happening for biomedical applications. And then certainly with the likes of our, large electronics manufacturers in the area, we have a large high-tech presence as well. So these are the four major industries that are currently operating in California. Of course, there's, others as well, but these are going to be the focus of the talks. So I'm going to start by talking a little bit about aerospace and defense and really where they're going and what their goals are, right? So for aerospace and defense, they want to limit the essentially footprint of their, vehicles. So airplanes cost a lot of money to fly. The fuel costs are going up constantly. How do we fly to different places in using the least amount of resources, right? So how do they do that? So what they do is they actually look for ways of autonomously driving their designs. So how do we automatically, without having any man on the vehicle, how do we actually operate this vehicle completely through robotics and computers, right? How do we limit the weight, right? So a big thing in aerospace is, maximizing the stiffness to weight ratio of all of their components. So that can be shaving off even 10% of the weight of a single component can lead to massive, benefits in terms of cost and time to market. So one of the major plays that is coming about in aerospace is the use of additive manufacturing. So for those of you who aren't aware, additive manufacturing essentially refers to 3D printing, but not only 3D printing of plastics, which has been available for a long amount of time, but also now we're focusing a lot on additive manufacturing metallic materials. Now there's certain printers and methods that can be used to do this. And really what it allows is for you to have more organic design. So you can actually shave off weight from places that, with traditional manufacturing limitations, you weren't able to do before. So additive manufacturing is becoming a huge player, and ANSYS actually has a nice workflow that customers use in order to start from a bulky design and then optimize that design for optimal stiffness to weight ratio using a tool called ANSYS topology optimization. And then ultimately simulating the print and getting a printed part out that really keeps that, maximization of the stiffness to weight ratio in mind. So if I just show the quick workflow here, we start from a typical geometry, right? And we have a certain set of loads and how is this geometry, constrained. And then we optimize that using certain optimization algorithms that are available in ANSYS. And what it does is it results in a really organic shape. Now, this organic shape would be impossible to manufacture using traditional manufacturing means, but now with the rise of additive manufacturing, you're able to create pretty much anything, right, in using a 3D printer. So what we have is then once you have the optimized geometry, we have workflows where you can recreate the geometry, modify geometries, etc., and then ultimately send it off to your printer to create a 3D printed part. Right, so that's one common example. So in our platform workbench, which is our project management tool for simulation, we have different types of analysis that you can run. So in this case, this is showing another example of our optimization where we have certain bulky representation of our part. This might be the initial part that we are looking to minimize the weight, and throwing it into our topology optimizer, it can remove out those certain, bulky areas where there's really no load transfer and no need for, and ultimately validate that design using FEA simulation as well. And then finally, you export that optimized geometry and you can send it off to your printer to manufacture that part. So Waleed showed a few of our partners, and this is another list of our general aerospace and defense partners. And you can see that, many of the commonly known names, like the big names, like your Boeings or your Rolls-Royce or your GE, all these companies are taking advantage of some of this technology in order to benefit or advance their time to market, as well as benefit them from an engineering standpoint. Here's another interesting example from a company called ANSYS. And what they do is they actually 3D print antennas, right? So with the use of ANSYS simulation, they're actually able to print these, antenna structures on a very large scale based on some of the information that they can obtain from ANSYS simulations. So purely through topology optimization and additive manufacturing simulation, they're able to, optimize their design, whether it be modifying the thickness of the walls or, modifying the heights of their designs. Those can all be optimized prior to even prototyping, which gives them a lot of flexibility in terms of design modification, as well as, how they can, rapidly test different design considerations without having to actually prototype. And this is just showing a couple of different areas of an aircraft where ANSYS can help, whether it's, designing the propulsion system, whether it's, the aerodynamics of the airplane. That would be done with, some of our CFD tools, even down to the avionics systems or the electronics that are on board. A lot of these things can be, optimized based on, what the heat is, how much deformations they get, how much stresses or mechanical stresses they obtain or see during their operation, etc. So the next segment is automotive. So automotive also carries some of the similar weights and similar requirements as aerospace, but another huge added one for automotive is the safety, right? So if my automobile crashes into a wall, is the passenger going to survive, right? So that's a huge thing, and that's really an area that LS Dyna, which is our explicit dynamic solver, excels in. It's essentially the gold standard for crash simulation. So any type of impact or failures with the actual mechanical or the chassis or the suspension system, all these designs can be optimized using ANSYS. And here's a listing of some of the popular automotive partners that we have. So you might recognize many of these names. And I happen to drive one of these cars, and it's not the one with the yellow horse on it. But you know, a lot of these companies are actually adopting the simulation in order to enhance their productivity in terms of design, as well as increase their time to market. So I just want to show a quick example. So this one is actually a multi-physics analysis. So when we use the term multi-physics, it's actually because we're coupling different physics together in the ANSYS workbench environment. So when designing an electric motor, you can imagine that there's a lot of things at play, not only from a structural perspective, but certainly from a electronics perspective. So for example, if you're looking at a electric motor, these designers actually want to know in real time, as this electric motor is operating, what is the level of mechanical or structural footprint on the motor or the components of the motor? Is there going to be any failures in the motor? Is there going to be any noise generated by the motor? How can we predict that noise, right? So this is actually a couple of different tools that are being used. One is the ANSYS Maxwell tool, which is used for low frequency electromagnetics. And then the latter two are actually capabilities of ANSYS Mechanical, where you can extract the dynamic capabilities of the stator and motor complex and the acoustic field that's generated from the operation of that field. So this is a 2D cross section of the Toyota Prius motor. So Toyota Prius is a hybrid, right? So it uses both electrical and mechanical or motors for operation. And so what we've done here is you can actually see from this Maxwell simulation that you're able to calculate the magnetic flux in a transient fashion. So as the motor is actually operating, you can see that, at different regions where you're getting your peak magnetic flux. And from that, you can actually calculate electromagnetic forces, right? So anytime you have a force of any kind on any structure, this could lead to deformations. It could lead to stress, which could ultimately lead to cracking or failure. So from the Maxwell simulation, you can also get a real-time prediction of, as the motor is operating, what are the electromagnetic forces that are acting on the teeth inside the motor. And then once you have that information, you can actually take that directly and map it over into a structural analysis. So in this case, we're using something called a harmonic response. So I'm not sure what level you guys are at in terms of what year you're in school, but eventually you'll get to a little known class called dynamics, right? And that in that class, you learn about how dynamic loading differs from static type loading, right? So in dynamics, you're tending to look at a force that is varying as a function of frequency, right? Or frequency dependent loading. So a harmonic response is a type of analysis similar to a shaker table, right? So if you take something and you vibrate it at different frequencies or a range of frequencies, you want to see the dynamic response of that system subject to those dynamic loads, right? And that's really what we're doing here. So as you saw from the animation, these forces are varying with respect to time, right? So that means that there is some frequency content to the loads that are being applied. So what we can do in ANSYS Workbench is we can actually connect up these physics and link them up in order to transfer useful information, right? So from Maxwell, we can actually transfer those electromagnetic forces into our harmonic response simulation so that we can evaluate exactly what the mechanical footprint is going to be on the electric motor design. So, when you think about a finite element analysis, right, there's multiple components that make up a vehicle, right? And whenever we run an analysis, we tend to focus, or, our designer tends to focus on a single part or a component within the model. But, there's always other aspects that need to be taken into account, right? So this particular geometry that's shown here could be connected downstream to something else, and via the tires, it's connected to the road. So somehow there's going to be some vibrational loading driven into this structure, right? So this is a substructure of the entire assembly, but you can suppose that there will be some loads that are driven into this design by components that it's connected to downstream. And that's really what the objective here is with this simulation. You're looking to see that as the electric motor is operating, you know, what do those forces tend to do to the structure? And then finally, once you have the vibrational content and vibrational results, you can run a vibroacoustic simulation, right? So anytime you've, you know, heard something vibrate, or, you know, we get earthquakes a lot, things make noise when they vibrate, right? So with acoustics, you can actually predict the level of sound that you're getting at any distance away from the actual structure. So if the electric motor is being designed to limit the noise, or sometimes even increase the noise, because, you know, you don't want to hit a pedestrian when backing up or things like that. You know, these types of questions can be answered by the designers purely based on physics simulations in ANSYS. Okay. So another common thing is to extract the resonance frequencies, right? So all engineering structures have a frequency at which they induce a natural vibration in the structure, right? So if anyone's played any string instruments, right? So as you tighten up the strings and then you play the note, it changes the tone of the string, right? Or the vibration, or the sound that's generated from that string. And that's because, you know, those strings have certain resonance frequencies, right? So the note A is like 440 hertz, right? So engineering structures perform the very same way. And really, we try to avoid designing things that are in resonance. So this is showing an example of that same electric motor, where we're looking at what are the natural frequencies of that motor. Because if you design something and it's subjected to a force at a frequency that excites resonance, chances are you're going to get a high level of stress in the design. And as we know, stress leads to mechanical failures, right? So modal analysis can be done in ANSYS purely by importing the assembly and running a natural frequency analysis to extract not only the resonance frequencies, but also the modes of vibration at each frequency. And then in terms of the, you know, electromagnetic noise due to the motor vibration, you can see that this is actually a plot of the acoustic field or acoustic pressure that's surrounding the motor as it's operating. So if you recall from the initial animation, we had the electromagnetic forces that were spinning, right, as the motor was operating. So you can see that as that's spinning, you're getting a certain level of acoustic noise that's being generated. And as you move further and further away from the source, you're seeing that the contours drop off, right? So you're at very close to the motor, you can hear a lot of noise. And then as you move further and further away, that noise will get dissipated into the environment. And, you know, as you move further and further away, the, you know, noise imprint or the sound imprint will be minimal, right? So again, you know, a lot of interesting types of problems and a lot of different physics are being solved in ANSYS. And, you know, this is just one example where multiple physics are at play, and you're actually incorporating all of those physics together in order to get some very valuable results that could be oftentimes very expensive or difficult to test for. Another really commonly used application of ANSYS is our usage of composite materials, right? So composite materials are essentially layups of materials. You know, very common composite is the carbon fiber material, and it's used very commonly in automotive. And it's used because it's so lightweight while still having a pretty substantial stiffness, right? So the lighter the weight, the less fuel required to drive, the, you know, higher the speeds you can obtain, etc. So, you know, the goal in automotive is very often to decrease the weight of the components, and also, of course, to decrease the cost. So composite materials are used very commonly, and in ANSYS, you're actually able to not only create those composites, but also run analyses on those composites so that you can evaluate things like interply failures, or evaluate the stresses that develop due to thermal impact or structural impact, and really get a great idea of exactly where those composites are at risk where you may need to thicken up the composite, and et cetera. And ultimately, this is showing a design of a particular vehicle that was reduced by 20% using just purely composites and ANSYS simulation. Okay, so the next industry I'm going to cover is the healthcare industry. So these are some of our partners. A lot of these have presence locally for us, but some of them are out on the East Coast. But you can see that we have a large spread of industry partners in healthcare as well. And if you think about a cardiovascular stent, right? So cardiovascular stents are used to expand blood vessels, in different types of applications. And there's really two types of physics that need to be considered, or two primary types of physics that need to be considered. First is the expansion. So what happens is that you actually have a balloon that's placed into the stent, and the balloon is inflated to increase the diameter of the stent and hold it there. And then the balloon is eventually removed to allow the blood flow to continue, right? So in this case, we have not only a fluid dynamics problem, right? So how is the blood flowing through the stent? And blood is a non-Newtonian fluid. Again, I'm not sure, where you guys are at with your education, but it's a non-Newtonian fluid. So, the physics of that become a little bit more difficult, but our CFD solutions can do a great job at calculating, what is the fluid pressure as this, depending on the flow rate of the blood, and how does that pressure actually impact the stent. So looking at this particular example, so this is a simple stent geometry that is being used from a mechanical perspective. And what we're looking at here is, exactly the physics of the, deployment of that stent. So there's a couple challenges with this. Namely, there's a nonlinear material modeling. So stents are generally made of shape memory alloys. So those are, different types of materials that can actually hold their shape based on, their loading history or electrical sources or different types of loading sources. And then you also have a significant level of contact, right? So between the stent and the surrounding vein or artery. And the geometry of stents can get pretty unique and it can be quite difficult to mesh and create, geometry for. So the benefits of using ANSYS here is that you can actually, without doing, inpatient testing up front, you can optimize the design of your stent based on simulation results. So in simulation, what people tend to do, especially in industry, is that as you're making design modifications, you run it through a simulation to evaluate, did that modification that I just made help the design by either reducing stresses or decreasing deformation, et cetera, or did it hurt the design, right? And from that, you can actually guide yourself into optimizing your design prior to even creating your first prototype, right? So limitations for stent design is that, all patients are different, right? All patients have different histories or medical histories, medical conditions. And, each time you run these analyses, using a couple of patients to test might not be the best way to go because, all patients are going to be different. Now, in ANSYS, you can actually define exactly the properties you want for the artery wall, the stent, and all that to see under different circumstances how the stent is going to behave. So this is just showing a couple of slides here on, exactly how this simulation was set up. So you actually have an initially compressed stent that, because the stent is initially going to be compressed, inserted into the blood vessel, and then expanded, right? So once you release that pressure, it's going to self-expand and hit the artery wall, right? So here's just a quick animation of exactly what this looks like. So you can see that initially we compress the stent and then we relax that pressure in order to expand the stent geometry. So all of this can be done, with a simple FEA model, so you don't need to go in and actually produce that stent and, start your clinical trials or what have you. You can do a lot of that experimentation and analysis up front, just purely through, ANSYS software. And, if you wanted to go even further in this analysis, you can actually incorporate the fluid flow as well. So we have a very powerful multi-physics capability, as I showed with our low frequency electromagnetics tool, Maxwell, but we have a more powerful capability also with CFD. So if you're looking at evaluating what the fluid pressures are that are being generated as you're passing the blood through the stent or the artery after the stent's been implanted, or you're looking to, take different patient-specific artery configurations or vein configurations, all these can be done in ANSYS. You can actually take these scanned images and bring them in as geometry into ANSYS, and then create your stent geometry also, so that you can evaluate the behavior. And then you can actually simulate in a transient fashion. So as the stent's deforming, what effect does that have on the fluid flow in the region, or the blood flow in the region, right? And then you can actually also pass that information back to the structural simulation so that you can incorporate the change in pressure gradients or pressure profiles in the actual stent. So I've covered at this point the automotive, aerospace, and healthcare industry. So now I'm going to shift focus into high tech, right? So in high tech trends, everything is now becoming computerized. I think everyone has a smartphone in their hand at this point. Everyone has laptops that are getting smaller and smaller, with things like tablets, surfaces, etc. So everything is the goal in electronics and high tech is to miniaturize, right? We want to make everything smaller, but we want to still improve power. We want to improve performance, and we want to limit the cost, right? We also want to, with the green initiatives, we also want to make everything more energy efficient. The more energy efficiency you have, the longer your phone battery is going to last. And then also we're moving into 5G, right? So everyone's heard about the big 5G movement. So how do we optimize that connectivity? How do we provide reliable and pervasive communication to the end customer? So how do we do this? First, just showing again, some of the customers that or partners we have that use our technology. So you can see many of your favorite electronics producers are partners with ANSYS, and a lot of these names are familiar to a lot of people. And one of the major challenges in designing electronics is really the sheer scale of the electronic designs, right? So this is showing a typical PCB board. So you can see that on the right-hand side, you have a lot of intricate details. If you actually break open a computer or something, you'll see a bunch of these PCBs in there, right? That are serving different purposes. You have your RAM, you have your motherboard, etc. And inside those PCBs, you have a really complex interconnection of different areas of the board. Now there could be chips mounted onto that board. And then you have all sorts of routing that, transfers signals from one point to another. And, the customers that work with us, their primary challenge is, how do I analyze this? Every time I print or prototype a printed circuit board, it costs me a lot of money. How can ANSYS help? How can ANSYS solve some of these problems, right? And so what we did a few years back, I would say about 4 or 5 years ago, ANSYS developed a technique called trace mapping. So what that enables is that it relieves the limitation that you're limited to mechanical CAD, right? So mechanical CAD would be, step files, SolidWorks files, Creo, NX, those types of files. But on the electrical side, the world is a bit different. So they don't use our SolidWorks and Creo. They use actual layout tools to create these geometries. And once they have those layouts, what you can see is they can actually bring those into ANSYS Mechanical. And once it has that in, we can actually calculate the effective material properties based on what the metal content is in the PCB. So you can see that in the analysis, you can actually calculate what the all this complexity of the PCB without actually having to import CAD for it. So with that, it gives us the ability to predict things like deformations, temperatures. If you're running a thermal analysis, you may have a heat source on the board where a certain amount of heat is being generated on certain chips, and that heat is being dissipated through the board. And you want to actually know what is the exact temperature profile that is generated based on these heat sources. So you can actually obtain that directly from ANSYS Mechanical using our heat transfer solver capabilities. And once you have those, you can actually feed that data, again, using ANSYS Workbench, into the board in order to track the deformation. So once you have the deformation, that can give you a lot of insight in terms of whether this PCB during operation is going to warp, deform. Are you going to get any cracking in the PCB due to high stresses? Are components going to pop off? Are components going to delaminate, or are adhesives going to fail? A lot of these questions can be answered even before prototyping, right? So as soon as you have the design finalized by the electrical engineer, that design can be brought into ANSYS, and you can start to run those virtual tests in order to assess the performance, actually during operation of that board. Another common analysis type that relates to the high-tech industry is solder joint reliability, right? So if you've never heard the term, solder is essentially a set of pillars that attach different chips onto the printed circuit board, right? So that they can transfer signal through the PCB, or the PCB can actually transfer signals to it. So the solder is a very, very fragile. It's actually, on the scale of microns usually, or a little bit less than a millimeter. So in those cases, the solder is actually very, very important, because if, you start to fail those solders, or you get a level of deformation or failure in the board, it's going to affect that solder. And once the solder breaks or cracks, you're going to get a failure of that entire electronic component, right? So a lot of times what, customers are doing, or ANSYS industry users are doing, is they're evaluating the direct stresses in each solder material through an analysis, as opposed to having to test for it. It also helps. So for example, in a testing environment, you might run, heat up your entire board to a certain temperature and check to see if it passes or fails, right? So let's say it fails. How would you know exactly which solder joint failed, right? It's, there could be thousands or tens of thousands of solders per component on each component that's mounted on the board. So how do you know if, which solder component is failing, right? So what ANSYS brings is that you can actually go in there and check to see exactly which solder joint is most susceptible to failure. And you can actually go and take some action in terms of either organizing the solder in a different way, maybe changing the soldering material in order to alleviate some of those failures, right? So not only can it help you in terms of your design, but it can also help in cases where something has failed and you're looking to find exactly why it failed, right? So that's a really important question in industry, because, if you can't figure out why something is failing and it's constantly failing, you're not only wasting time, but you're also wasting money. And, with the use of simulation and ANSYS Mechanical, you can answer a lot of those questions very, very quickly. And of course, I showed earlier for vibrations of the electric motor, but, for printed circuit boards, that's also a very, very common question that designers ask. You know, how is my design going to behave in a dynamic environment, right? So as I'm loading this up, I could be driving my components across the country on the road, or flying it through the air by plane, or shipping it by sea, right? And all these different scenarios can lead to different types of vibrational loads on the structure. So having an understanding of that is very, very important, because you want to make sure that you avoid you putting the design in an environment that it could fail under a dynamic type load. So again, modal analysis gives you a lot of insight in terms of the natural vibration characteristics. And that's generally done through an analysis called random vibration. So random vibration is a statistical technique, and what it does is it will enable you to evaluate the response of your design to a completely random set of input loads, right? So random vibrations generally work on something called a PSD, or power spectrum density. And the way, for, layman's terms, what that essentially is a representation of the environment that this board could go through, right? So if it's, different roads in different regions of the country have different PSDs, or power spectrum density profiles, different airlines or aircraft, or, have different vibration profiles, and different sea type or ship type shipping areas, whether you're in the Atlantic Ocean, Pacific Ocean, and Arctic Ocean, what have you. You can always have different PSDs representing the different environments that you're traveling through. And those can actually be directly input into ANSYS Mechanical to give you an idea of exactly how much deformation and stress you're going to get based on those loadings. So the last point here is on, drop, right? So who's dropped their phone, right? Pretty much everyone at some point has dropped some electronic device. And if you're lucky, nothing breaks, right? But a lot of times, your screen might crack, or the device might not turn on anymore. And, designers are constantly trying to put their designs in the most extreme environments so that they can avoid any, reliability issues with the product. So if it is dropped, they don't want it to fail. If it's dropped into the water, a lot of phones are becoming now waterproof. They don't want it to fail due to that. And then, all sorts of different types of extreme conditions, right? What is the angle at which it's being dropped? What is the surface on which it's being dropped, right? So with ANSYS, using our explicit dynamics tools like LS-DYNA, you can actually predict the performance of a printed circuit board or any electronic system during a drop, right? So a drop is characterized by a really rapid impact of load, or application of load at a particular location. So what designers are doing is they actually go through different drop test strategies. And what that is that you can drop an electronic device on the top, on the face, on the bottom, right, at a 45-degree angle. And they want to actually explore what is going to happen if they drop in these different configurations. And, testing that, could get expensive as well. Let's say you want to drop it at 100 different angles. That means you need 100 different prototypes in order to be able to drop, in those different regions. So with simulation, you can actually do these different tests purely based on a simple model. And actually there's tools in ANSYS that allow you to scan through different ranges of, drop angles, and, immediately get, not immediately, but, after a few minutes, get the response of that system at that exact drop height, at that exact drop floor or base, and, different infinite variations of really, conditions in which this could fail. So this just comes to my conclusion, and then after this, I'll stop to answer any questions. I see that there's some in the chat, but really the point I'm trying to convey here is that ANSYS has, a lot of different tools depending on what your training is in and what your overall goal is going to be as an engineer. So whether you're primarily focused on mechanical engineering, you could have a subspecialty of fluids or structures, or if you're an electrical engineer focusing on antenna design or things like that, we have tools that really cover all of those different areas. And the good thing about ANSYS is that our softwares are industry leading in all of these different areas, right? So we have very, very powerful solvers and capabilities in all of our tools. So today's presentation was really focused on some of the mechanical capabilities or types of problems that are being solved. But we have similar application examples in all of our different physics. And really the major point here is that, as long as you are, interested in learning ANSYS, it's not that difficult to learn. There's a lot of different tutorials and references out there, like Waleed mentioned, for you to explore and find out about. And really, regardless of what physics you're looking to solve, just be rest assured that we definitely have a solution for it. And the best thing to do is to reach out to Waleed or do some research through literature. And there's all sorts of people that are using ANSYS for different applications. So with that, I'll conclude my lecture portion. Yep, sure.
Thank you, Salman. So, we'd love to hear your feedback as well. I mean, is this, what did you think about the presentation? Is this what you were hoping to kind of get a glimpse of or get an understanding of as kind of ANSYS's presence on, academic side and also out there in the real world and kind of where our tools are being used and can anyone want to share some feedback? Was there something that you were hoping to see that we didn't quite explain or show? We can certainly try to, talk about that or show that or maybe follow up a later presentation. Justin?
No, yeah, this was perfect. I mean, this was exactly what I had in mind when I asked you guys to show this, because just because I guess just like we talked before, like I teach finite elements and I only have kind of one perspective, and I think my own industry perspective is pretty lacking, and so to see all the different variety of cases where ANSYS can be used in, and like all the capabilities has been really cool, at least for me to see, and I'm sure the students really appreciated that too.
Yeah, one of the cool things about the ANSYS innovation courses that I was describing earlier, it's not just like a tutorial for, okay, here's how you use ANSYS mechanical. Here's how you enter in your load, or here's where you put in your loads. Here's where you dial in your mesh. Here's where you hit solve. It actually kind of is a little mini course. It talks about a certain a topic. It gives an example. It goes into some case studies. Like it actually describes a problem and goes through how to solve that problem. So that's also something that I think would be really cool, again, to have in your back pocket if you have some free time, or if this summer after you're done with classes, if you just want to go and touch up on some of your ANSYS skills, or if you got some time, that's not a bad place to go, just to kind of get that feel and get some more examples under your belt as well. I put a lot of information in the chat because I just copied and pasted. So somebody asked, what applications were available in the ANSYS student version. So I didn't want to just, I expressed the URL, which is ansys.com students, but I thought I could just copy and paste and just dump it in the chat there, so you can quickly just kind of look through that. Those are the applications that are included there. But if there's a specific application that you're interested in that's not in a part of the ANSYS student version, for example, I mentioned electronics. So the ANSYS electronics tool sets for high frequency, low frequency, motor design, and things like that. Those, we can't just put that as a student version. So we've got certain royalty agreements and things like that with the companies that we've acquired, or the technology. There's some proprietary things that still haven't been fully patented, for example. So if you want access to those tools, or if you want to get like an evaluation copy, or just get your hands on it and start, kind of really learning it, let me know. Let Justin know, let myself know, and I'll try to get you a copy. What we can do is put one on the campus server, and it'll have a certain subset of license available, where you can just go in like you normally do right now with accessing the ANSYS license for class and just, check those licenses out. You just need to download the application, but those are available as well. Let's see, got some additional things here in the chat. Oh, Salman, were you open to sharing your PowerPoint slides with Justin and with the class? That's one of the things they were asking for.
Sure, yeah, I can do that. No problem.
Yeah, you can just send the slides to me, and then I can forward it to the class using our course website.
Sure.
Fantastic. So one of the questions were, in the ANSYS courses, are you able to get a certificate of expertise for specific physics? I believe at the end, it will just say that you've completed the particular course and the course name. I'm not sure exactly, a lot of the course names here, I can just pop up my computer here and kind of just share my screen, but a lot of them don't necessarily have like the physics applications in the name. But if that's something that you're interested in, certainly the things like the Cornell MOOC or the EDX platforms and things like that, those would be able to offer you like a specific certificate that'll say like completed ANSYS mechanical, for example, or something like that. Let me just share my screen real quick and just kind of give you a sense of what the courses kind of look like here. One second here, I lost my Zoom. Let's go into, let's make sure my browser is there. And then let's share my screen. Okay, so as you look here, so there's like fluid structures. Since we're talking about structures, when I go in, there's 36 structural courses. But what you'll see is the topics again are just talking about like a kind of a case study or like for example, topics in harmonic analysis. Let's just take the first one. When I click on it, it'll show you a course overview and kind of explains what you're going to learn. But at the end, oops, see full course. Here we go. At the end, I think it'll just say successfully completed, the course in topics in harmonic response analysis. So, but you can see here, like how to perform a mode suppression harmonic analysis, how to utilize residual vector method, how to interpret results correctly. There's a little summary, and then a post-completion survey, which I think will get you a certificate. This one in particular, for some reason, doesn't show that it has a quiz, or if you will. Some of these, let me just actually see if I can find one that kind of shows some practice assignments. So I think maybe the ones that I picked here are some of the earlier ones. I mean, some of the not beginner, but like very early in the introduction to a lot of these tools. Here's an example of one. What is this one? This one's called linear elastic models. But as you go down, so it explains like Hooke's law, for example, talks about linear elasticity, but then it says homeworks, quizzes, simulation examples. And then I believe, if I'm not mistaken, at the end, once you go and complete the survey, then you do get a chance to have some sort of certificate that you can print out. If that's not the case, for some reason, as you go through it, let me know. There's some other links here. I can send them all in an email to Justin for the other like websites that offer online courses where you would get a certificate. Another thing that I can offer as well is we've got ANSYS Learning Hub that we sell to our commercial customers, but what I'm able to do is offer it to academia for a 6-month period, for free. So in there, it's actually really in-depth as well. Not only is it like tutorials, but it's actually like on-demand virtual courses where it's for example, it's weekly. It's an actual live class, and you're participating weekly, just like you would now at school. You can communicate with the instructor. There would be assignments, and I believe at the end of those as well, you can get a certificate. So that is something that I'd be happy to offer the entire class as well, if that's something you want to take advantage of during the summer break or as you go into the next semester or quarter. So that one's called the ANSYS Learning Hub. Let me see if I can just pop that up here real quick. ANSYS Learning Hub.
I'm down.
It's kind of cool. What was that again? You've done that before?
I'm down with that. I want to do that.
Okay. Okay, cool. Yeah, so let's see here. Let me just show you. It's kind of cool. It says there's over 300 courses, self-paced videos, which you can do on your own, but then there's also like on-demand virtual classes. I believe in here as well, you get a certificate at the end of the course. So that's something that I've communicated directly with the academic marketing team. We are working on also like a badging type system as well. So similar to other software vendors out there where you can kind of go through and get like, I'm familiar with SOLIDWORKS before I joined ANSYS many, many years ago. And, you know, so I was, you know, you can get like different certificates for like sheet metal or, you know, finite element analysis or, and things like that. You know, you can become get an expert certificate or an elite certificate. We're coming up with that as well. We're going to have like a badging system as well. So as you go through and complete courses, you'll earn these badges that will, you know, you can basically, you know, have, on your resume forever, you know, like that you've completed these and that you hold these type of particular and hold this knowledge. So here's a glimpse of like the ANSYS campus, for example, because that's what it's kind of like a virtual campus. There's different buildings. There's like the mechanical and structural building. There's the fluids building, for example. There's electronics, electromagnetics building. So you go into these various buildings for, if you will, 3D design. So let me just pick the one that's like for structures, just to kind of give you, again, just more of an in-depth glimpse at what this is all about. You know, you can see here, you can choose courses by subject matter, by role, which is kind of cool. So let's say I'm an additive manufacturing expert or an aerospace engineer, and I want to focus on courses that fit that particular role, for example. That is something that this will be able to offer you as well. So you can see here all the different, topics and such, or the roles. If you scroll down, these are like the names of the courses if you just want to get a good list. And then at the very bottom is where we actually are advertising when our next virtual class is as well. So you can like sign up for those as well. There may even be an academic calendar in here somewhere. So the key to this one though is I submit a list of names. So Justin, maybe if it's possible, if you can just grab everyone's first and last names and then Cal State Fullerton email addresses, not like Gmail or anything. What I can do is I can enter them all in. That'll create a registration key that I can send out to you all, and then you'll all be able to sign up for this. And again, have access to it for 6 months at no cost. And this is what commercial companies actually pay for their employees to actually have, at work, for example. So this is pretty high end stuff right here. Versus the ANSYS innovation courses, it's free. It's available for anybody and everyone. And that's, that may not be in a university or may not work for a company that already, has ANSYS. So it's always good to just have more of these things. So.
Yeah, that sounds awesome. I think pretty much everyone in the class would be interested in that. So I think I'll send you everyone in the class's email and their first and last name. And yeah, that's great. Yeah, thanks so much.
Fantastic. Salman, I'm looking at one last question here. Generative design for heat transfer. That one is an interesting one. I'm not too familiar with that. Do you know if we have something, if our topology optimization tool sets allow you to do any type of conjugate heat transfer or anything like that? Or enter those in as inputs? Go ahead.
Yeah, so it depends on the nature of the heat transfer. So, whether you're using CFD or FEA to do that heat transfer. So FEA is generally better for conduction-driven heat transfer, not so good for airflow or any active cooling scenarios. But if you're doing it for like an FEA-based heat transfer model, then yes, you can do that. You can do topology optimization with steady-state thermal analysis, as well as modal analysis if you're interested. So it's valid for static, structural, modal, and steady-state thermal. So the answer to that question is yes, you can, as long as you're using FEA.
Great, thank you.
I got a quick question about cost. Some of these classes are free, but some of them are not free.
Which one are you talking about? Like,
well, these ANSYS courses that you have on the site there.
The innovation courses,
yeah,
they should all be free.
Okay.
Is there? Yeah, they should all be free. The only thing is you just would create a username and a password, so you just need to register. That should, it should be 100% free. None of them. I think it does say free. It is kind of confusing there. I just noticed. I think I remember. Yeah, see, it says free there. It kind of throws you off, but they're all free.
It implies that some of them are not free. So yeah.
You're correct. I see where you're coming, where you're going with that. Yes, but no, they're all free. You won't have to pay for any of that as you go through it. So
okay,
including the ANSYS Learning Hub. That's something that I'm able to offer to universities for a short period of time at no cost. So that will also be at no cost. The Cornell class that I was discussing with you earlier, you can attend that entire class for free. But at the end, if you want like a certificate, I think that's where you would pay money, I believe. So EDX, here's this one here. Like, for example, this one's edx.org, a hands-on introduction to simulation. So again, it's free, but then it says optional upgrade available. So then I believe that's just for like a certificate. Okay. So it's a lot more than I mentioned. I apologize. So $199 gets you the certificate at the end, like an actual, but you don't have to pay that to go through the course. So, and again, I've got several other URLs that I can share with you that have a lot of course content. If you just want to get as much ANSYS, examples under your belt as possible. So I'll send that your way. So great questions, though. Great questions.
All right. Do we have any other questions for Waleed or Salman before we close up for today?
I have a question. So I know that the free version is ANSYS Student, but is it suitable for, like, say, if you want to use it after graduation or something for your own personal stuff?
As long as, so you're talking about ANSYS Student after you graduate. As long as you have your EDU email address active, you're able to continue using it. And as long as you're using it for like educational purposes, right? Like if you can't use it for like consulting or making money on it, things like that, but you're free to use it for educational or, just learning purposes. I mean, there's nothing different in the applications between, what we offer for research for the university and the student, except for just the number of nodes that you can simulate, or, the density of your mesh that you can simulate. So that's the only thing where we kind of regulate is the size of your simulation. But besides that, you're free to use it as long as it's, again, for
non-commercial purposes,
paid non-commercial purposes. Yeah. And the campus university, right? So the campus license, the license we have at Cal State Fullerton. The advantage there is, so what's the difference between the student version and the version you have on campus? It's just we don't have a node restriction, so you can simulate however large of models you want, as much as your computer can handle, so that's the difference. Plus, I believe if you've got the ability to maximize and use more cores on your computer, you can also dial that up to like 16 cores or something, or not something, for sure. You can dial it up to 16 cores. So it's just to do larger level simulations for research or for school assignments or school homework and stuff like that, to be able to give you that. So hopefully that answers your questions, but keep them coming if you have more. I put my email address in the chat. And if you remember, the forum also has the ability to ask questions as well. So if something comes up and you misplaced my email address, or you can't find me, or if you just prefer to go through the forum, the cool thing there is, just like other forums you're familiar with, when you ask a question, the entire community has the ability to communicate and respond, and including ANSYS employees as well. So it's a cool thing to also register for. Alrighty.
Okay, it's 5:15, so I think that's all we got time for today. But let's thank our speakers one more time, everyone. All right.
Thank you for your time, everyone.
Yeah, thank you guys so much for coming. That was great. That was awesome. And Waleed, I'll send you the list of students in the class, and then we'll give them access.
Enjoy your summer, and I hope everyone
so
you know, passed this semester with flying colors. And if you're graduating, congratulations. And if you're graduating and you got ANSYS experience, send us your resume. We'll keep it. You know, we'll distribute it wherever we can with companies that are looking for ANSYS employees and stuff like that. We also have, I believe, areas on our website too where you can, you know, submit that as well. So thank you for your time. That's it. I promise I won't take any more of your time.
All right. Thank you guys again. That was great.